Thank you for joining us this evening in Big Data Mystified or Demystified, or is it AWS Big Data Demystified? All right, Big Data Demystified. Good. My name is Itamar Haber. I come from a company called Redis Labs. Basically, I'll say a little bit about ourselves in a minute. But if you want to learn more about Redis, this week on Wednesday, we're holding the annual Redis Day Tel Aviv for the 4th year in a row. You're free to attend. It's at the Trusk, a full-day event all about Redis. And we'll all be there, so feel free to come, drop by. We expect it to be quite an event. We already have 700 registrants. We'll see how many actually come, but still very exciting. So I promised you that I'll introduce myself. Here's my introduction. We are Redis. Redis, who among us knows or have heard about Redis? Very good. Uses Redis? All right, cool. So as my first and perhaps last slide says, it's an open source, the leading in-memory platform or database or data structure server or what have you. Basically focused around performance. Redis Labs is the commercial company behind Redis. We sponsor the open source project, we develop it, and we sell, of course, a host of solutions, commercial solutions for real dollars to our customers. I am a technological evangelist at Redis Labs and have been there for a few years now. Basically today, I thought about doing this kind of open discussion about Redis because I didn't know how many of you are already into Redis or haven't. I'll just skip through all kinds of things that Redis can do or what it is about, but the idea is that if you have any questions, you should feel free to stop me. Just raise your hand and ask your question. All right, any questions? Good. This is kind of like what Redis is about. It's the first paragraph from the open source's website. It's a mouthful. It tries to capture a lot. I won't bore you through all of the things right away, or you can read it and get like inspired by it, sort of. But basically, the things about Redis that I think stand out most or are most important to understand are these. Redis is an acronym. The name itself is an acronym for Remote Dictionary Server. And this acronym, and it's spelled or actually pronounced Redis, not Redis or something like that. The name Remote Dictionary Server basically says what it does. It is a remote server in the sense it's not supposed to be local to your application. It doesn't sit on the same instance. It could, but the idea is that it's a networked server. And basically what it does is it provides you with a dictionary. And the dictionary, for those of you who don't recognize it by that name, is a map or an associative array or just an object of sorts, field names and values. So Redis is that at its core. The nice thing about Redis is that it's free open source software. The core project itself is licensed under the BSD3 license, the Berkeley Software Distribution License, a very permissive license, which basically says if you want it, you can take it, do whatever you want with it. It's yours. Redis is an in-memory database or an in-memory data structure store server thingy, but you can use disk for optional persistence. So all the data in Redis is first and foremost managed in memory. The data can also be written to disk to survive failures, but everything has to fit in memory. And the guy who basically started Redis more than 10 years ago, but last week we celebrated Redis's 10th birthday. The guy is called Salvatore Sanfilippo. He's coming from Italy. He's the creator. He created Redis. He develops 99% of the open source version. Really impressive developer. He's coming to Redis Day Tel Aviv, of course. He'll give the keynote session. So again, if you want to catch him in action, you can. And he started it back at 2009. And basically said Redis, and this is not my definition, it's his definition, Redis is basically one of the things that it is about is providing a domain-specific language for abstract data types. If you recall your computer science lectures, you learned about data structures and data types. So Redis, in a sense, is a language to manipulate data structures. This is the essence of Redis. And Redis is a lot of things, but basically the two things that it's mostly about, or it's designed for, is performance on the one hand, providing ruthless, high top, very low latency performance at immense throughputs, while keeping it simple, which is a sort of a tough balance to achieve. It is designed for performance, and I'm saying this with gusto and feeling because a lot of thought into Redis's design has been spent on its performance. Starting from the choice of storage, which is currently RAM, and it's the fastest storage we could find for Redis. Even beginning with a manifesto that Salvatore wrote a few years back while starting to develop Redis. So Redis has a manifesto, which basically says what's Redis about. One of the lines in the manifesto is, we're against complexity. We don't like to do things complex. We don't like it when things are too complex for us as technical people to understand. When technology becomes too complex, it's blocking us. So we keep things simple. It's written in UNCC, so it also makes it very portable all over Linux and Unix, of course. It's implemented as a single threaded event loop, again, for performance reasons and to keep things simple. And it takes a lot of interesting decisions between certain trade-offs. You know, everything about computer sciences, or at least data structures, is trade-offs. It's either space or memory. So Redis takes a few unconventional approaches to solving these problems. It makes some things configurable, in the sense that you can configure the trade-off between space and time, between memory and CPU. And sometimes it just says, well, it's too hard to do something, so I'm not going to do it perfectly. I'm just going to do it sort of perfectly. Stuff like, for example, maintaining the key space. The idea with Redis is it's a key model server, or a key value model-based server. So you have a key name and you have a value. If you want to think about it from an SQL perspective, it's kind of like a flat table with primary key and some obscure value attached to it. So this schema is very, very simple. There are just key names inside the database. This is not interesting. And basically, the values of the strings themselves, the values of the keys, or the values stored under keys, can be all kinds of data. The simplest kind of data is a string. So this is the simplest kind of data type that Redis recognizes. You can store under a key up to 0.5 GB of string. And it doesn't have to be a string. The Redis strings are binary safe, so you can actually put everything there, anything and everything, binary data, a JPEG file, or just a text message. It doesn't matter. And Redis will be able to store that and fetch it for you. But the values in Redis, besides strings, can be of other types, and this is where it actually shines most. I'll show you a quick demo of Redis, if you will. There are many ways to consume Redis. You can run it in Docker, for example. If you want to, you can just, if you have Docker, you can just run Redis. Actually, Redis is one of the most, if not the most popular Docker container downloaded. There, over 1 billion or something. You do need to tell it a port. The default port is 6379, so you need to expose that. And if you've done that correctly, you should see Redis running on your machine. It will be pulled from Docker. Of course, I don't use Docker. I'm a real Redis geek, so I have Redis here. It's open source after all. So you go to GitHub, you clone the repository, you type make, and then you can just run Redis locally if you want, just like this.
Right. Awesome.
All right. And this is Redis, and this is the beautiful rendition of the Redis logo in ASCII. So showing a database is probably one of the most exciting things you can think about, right? Look at this beautiful black screen. But this is just the server. Now I'm really going to blow your minds and connect to the server with this amazing tool. It's called the Redis CLI, or the command line tool. And when I type and use the default, I get this prompt here that says you're now connected to Redis. Of course, this is not how my application would work. I have a client for every language that I need to work, but this is sort of interactive to see what goes there. So this is one of the things you can do with Redis. You can use the set command to set a key name. Let's call the key name foo, and then assign it with a string value, as I said before. Set foo bar. Redis responds to me with an OK, which basically means this operation has been successful or successfully completed. The nice thing about setting is that I can also do get. And if I do get foo, what do you think will happen? Very good. And you thought you won't like get what's happening here. You're getting it perfectly. So I've set foo to bar. I got foo again, and this is basically Redis. All right? Why would somebody need something like that? Like, I can do it in any programming language. I can set a variable and then read it. It's no big deal, right? I remind you that Redis is a remote dictionary server. It sits somewhere on the network. Right now, it's on my laptop, of course. But this foo key is now accessible to anyone connecting to Redis. So everyone can share this key called foo. And I can also, just to show you why you use Redis, I can revert to this little utility, Redis Benchmark. I'll just shoot it until it set foo bar a couple of times just to see how fast this can be done. So like just running it, the debug version actually of Redis on my laptop. All right. Just one sec. So just running this on my laptop, I get about 79, let's say 80,000 requests per second of setting foo to bar. So this is a pretty impressive throughput. And all of these, if you note, or most of them, at least reportedly, had completed in well under 1 millisecond and returned to the client who generated them. So this is the kind of performance we're talking about. Sub-millisecond latency for almost all operations, and thousands upon tens of thousands with the simplest setup, let alone a cluster. Yeah, question. All right. So this is why you use Redis. It's simple, set and get. It's not like rocket science. You don't have to be a Java programmer to do that. Like you can just do it. And it's very fast. In my book, fast and easy equals fun. I think Redis is a lot of fun. Probably never said that quite this way before. I said that Redis is a data structure server, so strings are fine and dandy, but there are other data structures that Redis knows about. It has a few core data structures. One of them is a hash. So if Redis is basically a hash table with key names and their values, it also knows how to expose the hash or the dictionary as a data structure for you to use. The string is just a string. It's a flat string, but there's another command called age set. Unlike set, this one is prefixed with age for hashes. And then I can say in the key called, I don't know, perhaps poo, I can put field 1, I'll call it field 1, with value 1, and then another field, perhaps F name, Itamar, L name, Haber, so forth. Redis responds with 3, meaning I just added 3 fields to that hash. If I'll try doing get poo, I'll fail because poo is not a string, it's a hash. So I get an error message, but I have an age get command that I can use, or perhaps even the age get all, just to see the entire key. And the values are return, field name and value, field name and value. So I can store a hash inside Redis as well. I can also do other tricks with hashes and strings. One of the things that strings are, or one of the things, the nice things I like showing about Redis is that although the string is a very simple data type, it can be used for storing, for example, numbers. So I have a command in Redis. All right, let's do it this way. I'll set a field called n to the value 0. Now, there is a command in Redis called incr. Incr, as its name suggests, increments the value inside a key, assuming, or not assuming, but rather providing that the value is, although it is a string, it's a string that represents a number. So if I'll try to incr my foo, which is bar, I'll get an error because it's not an integer. But n, as I set it to 0, is an integer, and incr n increments it by 1. I can, if I want, delete n and still call incr on n. And if the key does not exist, Redis automatically and implicitly assumes it should be 0 and therefore returns 1. There's also an incr by command if you want it. And then you can just specify an increment, for example, 9, and you get back the value. And other commands like these to decrement, you can actually increment by a negative number if you want to decrement, all sorts of like ways to manipulate the number. Why is this great? Because with one line, well, by setting Redis, and then with one additional line, I can create like my own counter or unique ID generator that can be hit thousands, if not tens of thousands of times every second in sub-millisecond latency to get my unique identifier. This is a very cool trick. You don't need to start synchronizing stuff. You've got this server that manages everything for you.
Is it thread safe if I have lots of clients that
Totally. So Redis, if you remember, is implemented, I mentioned that, as a single-threaded event loop. So everything happens atomically, and this is the beauty of it. If both of us go to Redis and ask for an incr, we'll be served by order. We can't step on each other's toes on the one hand, and on the other hand, the server is so simple because it doesn't need to log us out. It just does everything serially.
More than one server?
Then that's another case. But with 2 servers, it's a shared nothing, or more than one server is a shared nothing architecture. So basically, every key lives in a specific server. It doesn't live across multiple servers in most Redis implementations. There are others that we developed, like there's an active solution that my company sells, but it's not part of the open source, so I'd rather not spend time on that right now. So strings, numbers, what else can Redis do besides hashes? It also has a list. Lists are linked lists, you know, the one that start at one end, end at the other, and can be linked, and everything is interlinked between them. So Redis has that. The commands for manipulating lists usually start with L. So I'll start with L push. L push expects to get a key name, L, and then values. I can start putting in L A, B, and C. The list's length is 3. This is the response that I get from Redis. And I can L range, list range, key L from position 0, zero-based indexing, until -1, the last element, just like in Python, to get the list. Now, L push starts with an L, but it starts with an L not because it operates on a list, but rather because it performs a left push, or push from the left side of the list. We also have the R push command, and commands don't have to be uppercase. I'm just like used to typing this for emphasis. So I can R push into L, Z, X, and Y, and you'll see that these guys have been added to the end of the list, sort of. So I can push into the list, and of course, the one thing that lists are really good at, besides pushing to their ends, is, who remembers, why do we use lists?
Search.
No, search is exactly the anti-pattern of lists. You, my friend, need to go back to university. So let me, do you remember that I said Redis likes things to be transparent and simple and in your face, and perhaps not just like any other database? I used to be an Oracle DBA, an MS SQL DBA, a MySQL DBA, you name it. And all these guys, what they're expert at is basically giving you an automatic database that you need a DBA to tune and control and backup, right? And it's like a nightmare. It's very complex managing these beasts. With Redis, we try to do things a little more transparently. So let's take a look at the documentation of all things of Redis. Redis's documentation is part of the open source project, and it's online at redis.io. This is the documentation. Once you go to this website, basically you can download Redis from here and learn about it. I really like this page. It's just a flat list of all the commands that Redis knows. There are like 200 or so of them. But you can use the search box upstairs here. And let's look at, so you said search is a good thing for lists. I showed you lrange. Lrange, as an example, for a command, if you'll go to Redis's documentation, you'll note that like every command starts with this thing, time complexity. We are very upfront about how much time or how complex is the operation. Adding to a list, lpush, the time complexity is noted as O1. This is big O notation, like asymptotical computational complexity. And basically O1 is the greatest. It means like it's constant time. The data's size, the size of the value does not impact the performance of this operation. So lists are very, very efficient in pushing keys to either end. So lpush is done like that. Also, the other operation that they're very, very good at is lpop and rpop. This is popping the tail elements from the head or the end, doesn't matter, just removing elements, constant time. Anything like indexing or searching basically requires you to go through all the lists on average. So if I'll take lindex, which is basically what's the index of an element, you'll see that the time complexity here is O big N. O big O of N means if you have a list with 10,000 items, this is how complex it's going to be. So the idea with Redis and its data structures is that basically you need to know which data structure to use for what. And it's kind of like going backwards to school, reminding yourselves about lists and push and pop being their preferred operation. By the way, for hashes, the operation that you'd use a hash for is a lookup, because a hash table performs lookups in O in constant time. And there are other data structures in Redis. I won't bore you with all of them right now, but do feel free to like dive into this like wonderful documentation. There's also an intro to the data type. You've got everything here if you want to read. Now, over the years, Redis got a lot of interesting abilities. It's kind of hard to pick exactly which abilities you guys may want to learn about. So I'm trying to like throw tidbits on the floor, and whatever catches your interest, that's good. So the idea of this group is big data, right? I've been doing data since it was just tiny, like bits, and I moved to bytes. I did medium-sized data. Better. And right now we're doing big data. Big data is a lot of things. It's sorts of like, perhaps you know better than I do, because this is demystifying big data. I don't want to talk too much about big data and buzzwords, but show you two things I think may be associated with this kind of world. One of the things that Redis provides is data structures, right? And one of the niftiest data structures there is called the HyperLogLog. Anyone heard about the HyperLogLog beside Gal Sullivan? Okay. So here's a nifty little data structure that Redis offers. Arguably, it's not the most popular one. Not everyone needs to use it. But it's there and it's very useful, especially with big data. Here's the use case. Imagine that you have lots of information, what's called big data. Let's imagine that we have a log from a web server, but not like a startup's web server, but some serious company's web server. Let's call it Amazon, right? And this web server basically gets a lot of traffic throughout the day. One of the requirements that the company has is to count how many unique visitors have come to our website today. It's a very common request. Thinking about this request, counting unique visitors, we can envision ourselves going to the web server and scanning the logs of the web server, collecting the IP addresses that we've seen along the way, putting there somewhere, and then counting them, right? That's a great way, but it has just one shortage. You need ON of space and time, basically, to manage that. If there are 1 million unique IP addresses, I need to save all of these somewhere just to count them and dedupe them. And this tends to get very messy when the numbers get higher. So there was this French guy, actually doctor or professor, a mathematician, and he invented, actually statistician, and actually he invited this very convoluted way of measuring the cardinality of a set, that is, the number of unique items, without saving all of them. It's a probabilistic data structure. It's a sketch. It does not save the real data, but it saves enough information about the data so it can make a guesstimate or an estimate of the real thing. So instead of using ON space, the HyperLogLog uses constant space. In Redis's implementation, it's up to 16 kilobytes of space to count any number of things, unique things that it has seen. You can't retrieve the things. It doesn't know which things it's seen, but you can ask it how many things you've seen. And the reply it will give you will always be accurate up to 0.81%, because that's the way it's built. And that's good for things like you're going to Google and you're asking Google for, give me, like you're searching for something, I don't know, maybe porn. And then Google says there are 2,300,000,000,2,900 and so pages about this topic. You don't really need to know that it's 0.0% accurate, right? It's sort of orders of magnitude is good enough. And this is how it looks in Redis after this amazing introduction. It's just black and white on the screen. So the guy who, all right, to create the HyperLogLog, I don't need to pronounce it beforehand. I created it implicitly by starting to use it just like a string. I set the string. I didn't need to say, listen, there's a key called foo. I just set it to a string value and it happened. Same with HyperLogLog. The command to start the HyperLogLog is pfed, pf because of Philippe Flageolet, that French guy who invented it. And I'll call my HyperLogLog HLL, and then I'll just start putting in elements like A, B, and C. Once I've done that, I can ask for a pf count on HLL, and I'll get surprisingly 3. I can continue putting in elements along the line. Perhaps around the 100th element, I'll see that I have only 99 or 101 and so forth. But the idea is that, and if I'll ask Redis for this key's actual memory usage HLL, I'll get back it's 91 bytes, and I can do like pfed of something like very long. You can see that the memory usage has not increased. It's not keeping the actual value in there. It's just keeping sort of count, a very sophisticated count of the things it's seen. So this is one of the things that Redis is good for, I guess, for big data. We actually, as of last version, or the version before the last one, version 0.4, version 4 of Redis, Redis has gotten the ability to run custom modules. You can actually go, there's an API, you can write or develop your own custom modules in C or whatever language that it binds with C, and run your own libraries and logic. So we've extended Redis with a couple of custom modules that do other probabilistic data structures, such as cuckoo filters and Bloom filters and all kinds of nifty stuff that's kind of useful when you're dealing with big data and you need to keep, despite the bigness of the data, you still need to keep your data small, or some results and the statistics about it small enough. Any questions? Cool. What time did we start?
6:30. You have about 10 minutes.
10?
If
Yeah.
you want more, you can take.
All right. Yeah.
Can you say something about the examples and the products they uses this database?
Basically, Redis has a lot of use cases. You can use it. It's mostly used either as a cache in front of some other storage. It can be a relational database. It can be a NoSQL database like Mongo, perhaps, or any other disk-based database. It can sit in front of an API to cache its responses. Wherever you want to put it, it's as a cache. It's very powerful. I didn't show you, but it has a very rich set of capability that allow you to do caching intelligently, like expiration of keys. I have foo, if you recall, right? But I can say expire foo in 5 seconds. And foo is here for 5 seconds, but after 5 seconds, foo will be gone. So it's not there anymore. It expired. Very nice for a cache, right? And all sorts of other utilities like that, and memory management policies. So that's one thing. The other thing you'd see it as a primary database. That is a database that actually manages data. You'll see it in applications and products that require scale, throughput, and low latency. One of the known users of Redis, at least for some of their things, is Twitter. And basically every user's timeline is stored in Redis. So when you open your Twitter account and you see all the recent tweets, this is served directly from Redis. But if you look for Redis online, it's like all over. Everyone uses Redis for something, I guess. Yeah.
Thank you.
You talked about throughput and scalability, and well, you showed us that it can handle like 80,000 requests a second.
Here, this
How
machine.
can you scale that out? Like if you want to handle even more requests, like 200,000 per second.
First, I can actually show you how I can handle 2,000, 100 million, whatever's here. If where's my Redis benchmark? I can cheat a little, and maybe, what did I do? Set foobar, right? So this should like give me about 50. Oh. So you can see that I just reached the 7. So you can't see, but now you can see that I passed the 500,000 mark on my machine. I did a small trick there. I pipelined some of the requests, or 50 requests at a time, so I didn't have to pay time on the network round trips. That's one way of doing it, but the better way of scaling Redis, and this is not scaling, this is just like squeezing a little more, a better way of scaling Redis is called the Redis Cluster. And with the Redis cluster, what you do is basically, or what it does, is your database, your key space is partitioned, it's sharded across multiple servers, as many as needed, up to 16,000 if needed. Each of them can provide you a lot of operations per second. Without a lot of tuning, we get our production servers, every instance serve about 200,000 requests, but it really depends on the data size and the type of operations. But 200,000 requests per server is not unheard of. And then you just stack them. You add more and more servers to handle the load. And it grows almost linearly.
But do I have a single endpoint that I need to request to send my request to, or is it?
No.
You can send it to either server in the cluster and
The Redis cluster is reliant on what's called a smart client. So basically, the client needs to know about the topology of the cluster. But if the client doesn't know about the topology of the cluster, when you ask for a server for a specific key that it doesn't have, it will tell you where you need to go. Of course, to save on that, you can pull the configuration. The client can learn the configuration, say, all right, I know where everything is, and save this extra trip. But if it doesn't, then you'll get a redirect. 1 second. Yeah.
Yeah, it became from like a log function to an exponential function, but the data retrieval. Say before that you had like you retrieved 90%, 99% in like 1 millisecond, and now we retrieve 94 milliseconds. But I guess it like depends on like a constant.
This one, oh. Yeah, it doesn't make sense. Well, it's probably because of the pipeline, it gets things borked. I don't know, maybe because it actually
It counted
the entire
cluster,
pipeline,
it counted
the entire
cluster.
pipeline took up to 4 milliseconds. Sometimes it took only 0.4, but most of them they took like between 3 and 4 milliseconds for 50 commands to run in one go and return. And there.
Yeah, you talked about clusters. What about the ability for a cluster? Do I need to handle?
So Redis comes with actually a built-in sort of, there are 2 layers for durability, or it depends how you want to achieve high availability and durability. First, I mentioned it, you can configure Redis to be persistent. It actually, as a default, it runs with persistency.
What happens if I lose a node?
It depends on how you configure that. If you lose a node, then either you let the cluster run without full coverage, if that's what you want, or you can have the cluster say, I'm not available until you return the node. That said, Redis has a built-in replication mechanism, which we used to call master and slave, and now we call them master and replicas after being very impolitically correct. So we have, I've always said master and replica. You can ask Gal, we have that in our previous company, so I'm used. But the Redis community called it slaves. We just have replicas. A master replication is unidirectional from one master to multiple slaves. Slaves can have additional chained slaves if you want that. And you can basically use slaves for read scaling if you want to. But in the cluster, if you set it up correctly, let's say with a master and at least one master and one slave for each master, then the cluster knows how to automatically fail over the traffic and everything to the from the failed master to the slave.
And when the node returns, does it automatically rebalance, or you need to do something to it?
No? Why should it?
Because you now you have one replica.
If you return a node, then return the node as whatever you want it, as another replica or whatever. Usually, it's up to you.
We had 2 replicas, one of the nodes failed, now you
2 replicas?
you node to the
You have a
cluster,
master. You have one master and how many replicas? One
let's say
replica?
one master.
All right, so the master fell, you switched over to the replica, then you bring up the old node or whatever, and it becomes the slave. Or you can, like, if you really want to, you can tell now fail back, but why do that? Sorry?
Is it automatic, or do I need to do
No, it won't fail back automatically. It will just, you have to, if you'll rejoin the node, it will get configured as a node in the cluster. But there's no real reason to do a failback unless you have like primary site and backup site. And then you want to return to the primary site. But
You just lost one of the rest.
yeah, no. When you when you bring back the failed node, it will become a replica of the new master.
If we're talking about, sorry, if that's not interesting, I can ask later. But let's say you're using AWS instances and you just lost one of them.
All right.
So you bring one up,
You bring one up, you configure it, and it gets reassigned with.
assigned and rebalanced. Will it get
It will become a slave of, if your system was very simple, like 6 servers,
right?
and one of them fail, then it will become the replacement. You say, this is now the replica for the failed master, and it will be a replica of the new master.
From now on, or will it bring the old data back?
Yeah,
From now on.
all the data that there is from now on, like it will synchronize with the master, get a snapshot of what's happening right now, and then catch up. All right, sure.
I feel that involved.
Okay, no worries. So another thing, and I don't have enough time to show it, I'll just mention it. Latest version, version 5, the feature that everyone were most excited about, or the reason for that feature, is called streams. How many of you have heard about Apache Kafka? How many of you are using Apache Kafka? 1. Okay, cool. What's the problem with Apache Kafka? Or what's the challenge with Apache Kafka? Redis is? That's all I have to say.
You can talk about it if you like. A couple of
I can show you streams. It's basically inspired by Kafka, the same idea or same notion, a streaming system or a stream processing system in which data enters in a stream, an ongoing stream, and you need some way to buffer all the messages, and you want to like smooth irregularities if there are peaks, and you want to consume the stream as it comes and build the sort of event-driven processing system. Very popular today with microservices or what you name the buzzword, it's there. And Apache Kafka basically gives you this distributed streaming solution or message broker that lets you shove messages in an orderly fashion, in an ordered fashion without losing them outside. And the problem is that it's good, but it's very complex to set up and maintain. It requires setting up Zookeeper and Apache Kafka. You need to set up 2 clusters, blah, 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 and it becomes more complex. Redis does its own thing. The idea is, like the inspiration is the same, but the implementation is totally different. It's in memory, so it's a little faster. And just like anything else in Redis, you go to your CLI, or if you're a programmer, you go to your favorite programming language, whether it's BASIC or, And with streams, we have the X commands. Do you know why we use X for streams? Because we ran out of letters. Really. But then all you need to do is like xadd is the command to start creating a stream and start populating it. So xadd, here's my key, I call it stream. I'll let the Redis server decide or auto-generate the stream's message ID, and then like a hash, I put fields and their values. So fname, Itamar, lname, Haber. This basically means this stream has been added with a message. I can and this is the message identifier for that message. I can add 1,000 messages to the stream. The stream now has 1,000, the same message over and over again. I can read, or I can range the screen, xrange, stream. So, oops. So xrange starts at this beginning of the stream and gives me like chunks. I can say start here or start there and limit the count. This is like going from the beginning of the stream to its end. I have, just like xrange, I have the xrev range, which is the reverse range. So this starts at the end of the stream with the newest message and basically continues downwards or upwards the stream, like salmons swim up the stream. So this brings me the messages in reverse order. There's a notion of blocking reads. I can like sit on a stream and wait and have my client block for messages until they come. So providing me this kind of asynchronicity. Very, very nice patterns if you're doing stream processing. This is kind of like you already have Redis in your application. You just start using streams, and maybe later on you go and upgrade to Apache or whatever if you need it.
Can you talk a little bit about performance metrics of stream? How many events per second can it handle?
Same. It's so one of the things we at Salvatore tried doing very in Redis generally, but streams as well, is make sure that performance is not sacrificed. So if you go to the stream command, it's xed, it's the main command. You'll see that it completes in O1 complexity. So whether your stream has one item in it or whether it has a billion items, adding new items will always be at the same time. Reading is, again, it happens like that. It's just a matter of load. So I can push messages to the stream very easily. Same numbers as set and get, not really different. Yeah.
What is the advantage of Redis compared to Hazelcast or any other?
Well, I don't sell Hazelcast. Hazelcast is open source, or yeah, you sure? I think Hazelcast, if I'm not mistaken, is Windows for one. Secondly, Hazelcast is not exactly the same. They position themselves as an IMDG, if I'm not mistaken. I may be mistaken, an in-memory data grid. And an in-memory data grid is not exactly the same as a database server. Like, it's more like distribute the database among the application inside the the stack of the application, or extend the stack. If it's Java, then you need more stack. But it's not a server. It's a different topology. It's a different product. You can achieve similar effects. Like there's a leak between them. So sometimes IMDGs are used as a cache in order to make things go faster. There is a comparison page between Hazelcast to Redis on Hazelcast's website. We do not put the response to them on ours. Apples and oranges. Yeah.
How many readers can read from stream?
Sorry?
How many readers can read from stream simultaneously?
No.
Kafka, it's like you can read by partition, right? So
Yeah, you can do partitioning here too, of course, but from a single partition, there's no limit. Like, only your server is the limit. And usually what we see, by the way, it's not the CPU that's the, well, the number one resource that Redis uses is memory. So you have to provision it with enough memory for the data. Then what you see, the bottlenecks that we see in production are usually first and foremost network. The network, even a 10G network, 10 GB network can't catch up with what Redis, a single core of Redis does. It saturates the entire NIC. Not to mention if I'm running a scaled like cluster on the machine, then forget about it. And sometimes the CPU. So once you solve one bottleneck, another comes immediately. Cool. Thank you guys. It's been a pleasure.